Good afternoon, students. Today we are going to see analysis of structures. So today we are going to solve this particular problem using method of joints. What are the things we are going to calculate in this problem is we are going to calculate each member force, and then we are going to define whether the member is in tension or compression. Here if you see the problem, so they have given three joints, that is A, B and C. In joint B and C, you can see that there are supports are there. One is in joint B, we are having pin joint support, and in point C, you are having a roller support. As we discussed earlier, trusses are connected by pin joints. And in point C, you can see that it's a roller support. So along the direction of the rolling direction, you won't have any reaction. So opposite to that, you will have one reaction in that particular support. And the dimensions, you can see that from the point C, the A point is in 3 meter, and from the point C, the B point is 3.2 meter in vertical distance, and from the point B, the A point is around 4 meter in the vertical direction. So based on the given problem, A, B, C, or the member truss, okay, each one is a truss member, and then you can see that the points are A, B, C. And then at point A, you know that 48 kilonewton is acting. And point B, as I said, it's a pin joint, so or hinge joint, you are having two reaction. I am assuming the direction that the vertical reaction with respect to the support, it is Bx, and with respect to the support, the horizontal direction I am taking as By. After that, when you come to the point C, it is horizontal reaction. But as the support, it is actually a vertical reaction. So this point is Cx. So once again I will repeat. Okay. Now, so we are going to draw the free body diagram of this particular diagram. So 3 points are there, A, B and C, and these are the members A, B, B, C and Ca. And you know at point A, 48 kilonewton is acting. And point B, you are having two reactions. One is Bx, another one is By. So these directions we are assuming. So based on the answers, we can check whether our assumptions are correct or wrong. And point C, you know that we are having one more reaction, Cx. Obviously, Cy will be 0 because roller is placed in the directions. Vertical reactions will be 0. What are the forces are acting? 48 kilonewton, and you are having a reaction at C, and you are having two reactions at B. So based on this, if we are drawing the equilibrium diagram, otherwise if you are considering the entire system is in equilibrium, then take the x and y axis. So I am going to solve this particular problem in the resolution of forces first. After that we will solve in Lamy's theorem. So first in this category, we are going to take all the forces with respect to x and y axis. So you know that all the horizontal forces are acting from left to right. So all the forces are in the same direction. This is your 48 kilonewton, and this is nothing but your Cx and Bx. So all the forces are in the same line. All are positive as per our assumption and the given value of 48 kilonewton. Next one is the vertical axis. You have By, that is towards up. So based on this particular consideration of forces, so if you are calculating our equilibrium condition, that is summation of horizontal force equal to 0, summation of vertical force equal to 0, then you can see that the first equation I am assuming that summation of horizontal force equal to 0. Why I am giving 0 means because it is, we are assuming the structure is in equilibrium condition. Then obviously the equation will be Bx plus Cx plus 48 is equal to 0, because you know that two reactions we are assumed in the same direction of 48 kilonewton. So all the forces are in same direction. So I am adding all the forces, that is equal to 0. And once you are equating like that, then we will have an equation like Bx plus Cx is equal to minus 48. That is the first equation. Next one, I am substituting the next equation, that is summation of vertical force equal to 0, that is Fy is equal to 0. I am assuming that upward is positive. So here we are having only one vertical force, that is By, then that is equal to 0. So based on these two equations, we are unable to solve Bx and Cx. So we are having one more option, that is summation of moment about any one particular point in the structure is also 0. So we are going to calculate next, that is moment about any one point. Now I am giving you the same thing, that is 48 kilonewton, and we are having two forces Bx and By in B and Cx in C point. So now we are going to calculate moment. So moment, as we discussed earlier, so moment is nothing but force multiplied with the perpendicular distance with respect to that same point from where you are taking the moment. So here we are taking the moment about C point. So I am taking the point C first, and then you know that at point C there is a force called Cx is asking, that is nothing but reaction force. And then I'm coming to the point B. In point B we are having two forces, Bx and By. And one more force is acting in the system, that is at point A, that is 48 kilonewton. So now based on the point C, I am going to calculate the moment. So for calculating the moment, apart from the forces, I need perpendicular distance. So we are going to calculate one by one the perpendicular distance. So the first one, when you are considering with moment with respect to C, obviously the force acting at that point will be equal to 0. So we can cancel the term. And one more thing, with respect to C, the point on B, the vertical reaction By is also in the same line, so it won't have any perpendicular distance, so you can cancel the term also. So now you will have only the effect of Bx and 48 kilonewton. Those two forces will create a moment with respect to C. Now I am calculating the perpendicular distance from C to B, that is Bx force, that is 3.2 meter given in the problem. Similarly, I am calculating the perpendicular distance from the C point to the 48 kilonewton, that is 3.2 meter plus 4 meter, totally 7.2 meter. So based on these two distances, so I know the forces Bx and then 48 kilonewton I can substitute. As like equilibrium condition, third one is moment about any one point is equal to 0. Here we are considering C point, so moment about C is equal to summation of moment about C is equal to 0. We are assuming that the clockwise moment is positive. So the first force I am taking the Bx multiplied into 3.2 meter. So obviously the Bx force will rotate in clockwise direction with respect to C. So I have taken as positive. And one more, 48 kilonewton also will rotate with respect to the point C in a clockwise direction. So 48 into 7.2. So if I am multiplying and then if I am substituting the values, then 48 into 7.2 and Bx into 3.2, obviously we will get the value Bx is equal to minus 108 kilonewton. We have assumed that the Bx is acting towards right, but actually it is acting towards left. That is the meaning of the answer. So if suppose that if we are getting the answer as positive 108 kilonewton, then whatever our assumptions are correct. But we got the answer as minus 108 kilonewton. So obviously it is acting quite opposite to our assumption. So it is acting towards left. Okay. This is the information we have to get it from this particular answer. Okay. So next one, so after calculating the Bx value, now we can calculate the other parameter, that is Cx. Based on the first equation, please substitute the value of Bx in the first equation. You will get Cx value. So whatever assumption we made in Cx is correct because we got the Cx value as 60 kilonewton. Okay, so we got Bx and also we got Cx now. So it's all about the moment calculation. Based on that, we have calculated the reaction force at C and reaction force at B. So now, as we discussed earlier, we are going to calculate the member forces. Okay, in this particular Truss problem. So we are having three members. In the three members, what are the forces are acting? We are going to calculate that by using method of joints method. We are having point C, point B, and then point A. So you know the forces Cx, Bx, and then 48 kilonewton is acting. So now in the method of joints, first we are going to consider joint B. When you are considering the point B, you know that we are having the force Bx. So now I have changed the sign because I knew that it is acting towards left. That is 108 kilonewton. And next force that is acting on BC, the member force. So I am taking it as FBC. And the third one is the force which is acting on BA member, that is I am taking as FBA. So again I will repeat. So one is at point B, we are having Bx force, that is reaction force. After that you are having a member force FBC, and then you are having a member force FBA. So once you have calculated, obviously C point won't come because we are calculating member forces with respect to joint B. So you can simply remove that. So now you have to calculate the angle so that we can substitute in a resolution of forces, and then we can find the unknown forces acting on the members. Otherwise we can use Lamy's theorem. So first one, I am going to calculate this particular theta 1 because I knew that already the FBC with horizontal it will be 90 degrees. So I want to know the value of theta 1 now. So theta 1 from the geometry we can calculate. So in the geometry it is given that with respect to B point, the A point is in the vertical distance, it's 4 meter. Similarly, from the B point, the A point is in the horizontal distance 3 meter. So by using tan theta is equal to 4 by 3. So we can substitute. So tan theta is opposite by adjacent. So if you are substituting, you will get theta 1 is equal to 53.13 degree. So you can substitute same thing in here. So once you are substituting, now the angle between the force FBA and the force FBC is 90 plus 53.13, that is 143.13 degree. Okay. So similarly, if you know that from point B, that Bx and FBC, if you see, then obviously that angle is 90 degree. So once you know that is angle between FBA and FBC is 143, and the angle between the force FBC and Bx is 90 degree. So the total included angle is 360 degree. From 360 degree you can subtract so that you will get the angle between force FBA and Bx. Okay, that is 126.87. Once you know the included angle of three forces and that forces are in equilibrium in a system, you can go for Lamy's theorem. So first one is the force I am taking FBA. So the included angle of remaining two forces, that is FBC and Bx, is 90 degree. So FBA by sine 90. Similarly, if I am taking the force Bx, I have to take the included angle of other two forces, that is FBA and FBC. So that included angle of FBA and FBC is 143.13. So I have substituted Bx by sine 143.13. Similarly, when I am calculating for FBC, so the included angle of Bx and FBA is 126.87. So once you are substituting that, you can get the answer of FBA and then FBC. Okay, that's the thing. So FBA will come 180 and then FBC will come 144. That's the thing. So if you are not getting, so this is the answer. Okay, FBA is 180 kilonewton and FBC is 144 kilonewton. So how to solve the same problem by using resolution of forces, I want to explain to you. So same diagram I have taken now, and then now we are going to solve, instead of Lamy's theorem, resolution of forces. So in the resolution of forces, as we said, summation of horizontal force is equal to 0. So now you can say, take that Bx is in the left hand side, so it will be minus 108, and then the FBA force along the horizontal will be FBA cos 53.13 will be equal to 0. FBC won't come because we don't have any horizontal in that point towards C. We are having only vertical component, so I am omitting the FBC. After that, you can substitute summation of vertical force equal to 0, that is upward is positive we are taking. So FBA sin 53.13 is positive minus FBC because the force acting on member BC is acting towards down, I have assumed it. So based on the answers, whether our assumptions are correct or wrong, we will take it out. So FBA sin 53.13 minus FBC is equal to 0. So once you are substituting FBA value, that is already we have calculated 180 sin 53.13 minus FBC is equal to 0. we are getting the value of BC is equal to 144 kilonewton. So our assumptions are correct. Based on the first equilibrium condition, summation of Fx is equal to 0. We got FBA is equal to 180 kilonewton. That is our answer. So now you can take the point B, C and A. And now you know that we are going to consider the point C. So Cx is there. It is acting towards right hand side, that is positive x-axis. We know the value, that is 60 kilonewton. And you know that from the C there is a member force acting towards B, that is FCB. And then there is a force from the C, it is acting towards A, so that is force FCA. And we have this one also, we are assuming it. Okay, these forces, that is Cx we already got, that is 60 kilonewton positive, so our assumption are correct. Now we are assuming that there is a force which is acting from C to B, that is FCB, and from C to A, FCA. Okay, same way we can calculate the angle. This one we have already calculated, that is theta 2 is equal to tan theta 2 7.2 by 3. So the theta 2 value is 67.32. So tan inverse of 7.2 by 3 you can calculate, you will get 67.32. So once you have calculated that, then remaining angle, you know that because Cx and FCB having 90 degree inclination, you can simply subtract 90 minus 67.38, you will get 22.62. That is the angle between FCA and FCB. So once you got the angle, so you can relate the angle between FCB and Cx, that is 270 degree. So by using this relation, you can substitute Lami's theorem. So the Lami's theorem, you know that the force Cx, okay, if you are considering the force Cx, the other two forces included angle is FCA and FCB, the included angle is 22.62. And if you are considering force FCB, the included angle between Cx and FCA is sine 67.38. And then if you are considering FCA, the included angle between FCB and Cx is sine 270. So if you are substituting, you will get the answer FCA is equal to 156 kilonewton. And you can verify that whether our answer is correct or wrong by comparing that BC value with FCB. So both the values we got 144 kilonewton. So we got the force, the member force in AB, and we got the force that is member force in BC, and we got the member force in CA. So now, as per method of joints, we have calculated the member forces. So after calculating all the member forces, so we can whether the truss members are in tension or compression. So if you are considering C and B member, so based on the value whatever we have got, it says, so we have made whatever we have calculated, according to that this particular member is in tension. Okay, and if you calculate based on the calculation of forces, the B and A members are also in tension. Okay, so based on the calculation of the forces in the member of CA, we have found that that particular member is having compression force. Okay, so this is the way we have to give the answers or solution to this particular problem. Okay, so you know the values, whatever we have got, we have got 180 and kilonewton, and then 144 kilonewton, and then 156 kilonewton. Okay, so based on these values, we have found that member CB is in tension, member BA is in tension, but the member CA is in compression. To practice, so please do this problem and then post your answer in the comment box with your name. Okay, thank you. Have a nice day.